Okay guys, welcome back yet to another video. This evening we're going to look at relations, functions and graphs, part 1. Alright. So we're going to look at what we call the Cartesian plane, and that's the foundation of what a graph is. Now, a Cartesian plane where we have two lines that meet at right angles. A horizontal line and a vertical line. Now the name of the horizontal line or axis is called the x-axis, and the name of the vertical axis is called the y-axis. Alright? But sometimes I use those words interchangeably. Alright, what's the purpose of the Cartesian plane? Well, we use it to plot points. And hence we use Cartesian plane to draw graphs. And when drawing graph, we use a system of rectangular coordinates. Alright, now an example of a point. Let's say we have this point here. M is 9 and negative 5. Now the M represents the name of the point. The 9 represents the X coordinate. And the negative 5 represents the Y coordinate. Alright, so we always write the X coordinate first, followed by the Y coordinate. Okay, another note down here. X-axis. That should be there. So the x-axis consists of x coordinate, likewise the y-axis. And here we make this point down here that, this is how we write a point. The x coordinate or values first, followed by the y coordinate or value. Now it's noteworthy that singular was the axis. So x-axis and y-axis. So plural, say axis. Now, the set of x coordinate or values is called the domain. And the set of y coordinate or y values is called the range. Another name for range is codomain or the image set. Alright. Okay, let's take a closer look at the Cartesian plane. Okay, so the Cartesian plane is divided up into 4 parts, as you can see. So we have the horizontal axis called x-axis, followed by the vertical axis or the y-axis. So what they do, they split up the Cartesian plane into 4 parts. So this part here is what we call the first quadrant. Over here, the second, followed by the third, followed by the fourth quadrant. Quad means quarter. As you can see, this is actually 90 or a quarter of the entire 360. Now, let us look at the horizontal axis. Over here, this arrow here is going to the right. Now, these values, they are positive and increasing. So like you have 1, 2, 3, 4, 5, 10, 20, 30, 40, 50, etc., etc. However, going along here, these values, these x values or x coordinates will be negative and decreasing. So if you have -1, -2, -3, or -10, -20, etc., etc. It's pretty much like a number line, if you notice. So going up, these values are positive and increasing. And going down, these values are negative and decreasing. Alright, so going down, these are negative and decreasing. Oh boy, my handwriting is atrocious. All right, okay, now let's zoom into this. Remember, what's the purpose of a Cartesian plane? To plot points. Now, in the first quadrant, all the points, the x coordinate and the y coordinate, everything is positive. So all of this, everything right here, so in the first quadrant, the x values are positive and the y values are positive. And in the second quadrant, all these points here, what you notice? The x value is what? Negative, but the y value is positive. In the third quadrant, the x value would be negative and the y value would also be negative. So everything down here, so in the third quadrant, everything is negative. All right, what about the fourth quadrant? Can you tell me the answer? For the x-axis or for the x value, would it be positive or negative? It would be positive because it's on this side, so it's positive. However, the y value, since the y value is down on this side, the y value would be negative. All right. So let me, not sure what's happening. Here. Okay, so this slide, trying to get my marker. All right, guys, so plotting points. All right, so look at this question. So we want to plot the following points: J, K, L, and M. So now J, let's see if I can let me let's get something over here. So I'm not going to be able to write in the numbers. Just going to use diagram on the left. All right, so we want to plot the point J, which is 6, -2. Now the 6 will be the x value taken from the x-axis. So right here we have 1, 2, 3, 4, 5, 6. So right here so would have been the 6, and y is -2. -2 is down here. So where the 2 points intersect. Right, so that's our J. K now. Can somebody tell me which quadrant K would you find K? It would have been the first. Why is that so? Because all these values are positive. So x is 2, which is right here, and y is 4. 1, 2, 3, 4. So there goes my K. L now, x is -3 and y is 4. So x -3 is on this part here, is -1, -2, -3, and y is +4. So it will coincide with that intersection here. So that's L, and that's in our second quadrant. All right, look at M now. M is very interesting. All right, now x is 0. Where is 0? It's in the center. And y is -2. Well, y is -2 is right here. Right. And I think I almost forget something to mention. Let me see if I can go back. Let me not go back. The center, this is actually called the center of the Cartesian plane, or the origin, or O. And that coordinate is 0, 0. All right. So the question says to join them in alphabetical order. So we have J. So J will go to K. L, M, and I would believe they would want to close that. Right. All right. Can somebody tell me what shape is that? It's actually a rhombus. Moving on. All right, so we're gonna look at how to draw simple linear graph. All right, that is very simple. All right, so it says sketch the graph of the following. All right, so it says sketch a graph of x equal to. Let's use this diagram down here. Well, where would you find x equal to? Well, it says x, so that would have to be on the x-axis. So right here. Alright, so the line x equal to is just a vertical line passing through 2 on the x. And always label your graph. So that's x equal 2. So the same way you draw x equal 2, same way you draw x equal negative 3.5. It's only that it's going to be on this part here of the graph. So let us say this is negative 3.5. It's just a vertical line passing through negative 3.5. And that's our graph. All right. I think this marker is thick. Move the sides. All right. So let's look at part 3. Sketch a graph of y equals 4. So it says y. So I'm thinking the y-axis. And you'd find positive 4. Let us use this graph down here so below. Y equals 4 like this. So it's just a horizontal line passing through 4 on the y-axis. And you always label your graph. Same way you draw y equals 4, same way you draw y equals negative 3. So it's going to be on the downside. Alright? Alright, now draw the graph or sketch a graph of x equal to 0. Alright. Now let's go over here. Let's use this graph for example. If we were to ask to draw the graph of x equal 1, it would be something like this. It will be a vertical line passing through 1. If we ask to draw the line x equals negative 1, it will be a vertical line passing through negative 1. If we were to ask to draw the line x equals 0, it would have to be this line here. But the line is already there. And would you agree with me that line is actually the y-axis? So when it asks us to draw the line x equal to 0, that's actually the y-axis. Let's look at this one now. If we're to ask to draw the line y equals 1, it will be a horizontal line passing through 1 on the y. If we're to ask to draw the line y equals negative 1, it will be another horizontal line passing through negative 1 on the y. So if you're asked to draw the line y equals 0, it will be a horizontal line passing through 0 on the y. And wouldn't that be the x-axis? Alright, so please take note of that. Alright, moving on. So I find that I have to erase everything. Okay, so our next subtopic, we're gonna look at what we call the inequality signs. All right, so inequality sign, we have 4 of them. So this one is the less than sign. You notice it looks like an L. All right, so another phrase that we could use to describe less than, we could say fewer than. And the one below is less than or equal to. Another phrase that we could use to describe that one is no more than. The third one here is greater than. Another phrase we could use is more than. And the last one is greater than or equal to. And another phrase that we could use to describe that is at least. So basically, I could say, okay, I have at least $100. That means that I could have $100 or more. If I say I have no more than $100, it means I have $100 and less. If I say I have fewer than $100, it means I don't have 100 but less. All right. So moving on. Now, how do we represent an inequality on a number line? All right. So just in case you might be wondering, this thing here is a shadow of the phone, and something that I use to hold up the phone. I was trying to get rid of the shadow, but I couldn't get rid of it. All right, so well, we all know what a number line is, right? It's a line with some numbers on it. So it says represent x greater than 5. Right, so I'm going to use the first one here. So I have 1, 2, 3, 4, 5. So now greater than would mean that it is more than 5. So on the x-axis, going to the right is always positive and increasing. All right. So I would want to go that way. All right. So that's the first one. Now notice that this circle here is open. And it's open because it's greater than. Let's look at part 2. Part 2 says x is less than equal to -4. So 1, 2, 3, 4. So it's right here. Because this is less than equal to, it means that this interval here is closed. So we shade that part. So it's less than, and you're going to the left is negative and decreasing. All right. Okay, part 3 now sets up a little bit different. As you can see, this represents an interval starting at -1.5 and ending at 3.5. All right, so notice that the less than equal to less than equal to indicates that those two ends are closed. So let's say this is -1.5, argument's sake, and this is 3.5. So it will start at -1.5, and that end is closed. You go that way, and at 3.5 it's also closed. So you shade it. How do you know it's closed? Because it's less than equal to less than equal to, or it could have been greater than equal to. All right. So all of this section here is an interval starting at -1.5 and ending at 3.5. All right. So the last one now, we'll start at 3. And you're going to end at 5.5. So let's say this is 3, and that's 5.5. So notice at 3, the interval is closed. So we shade that part. However, notice that at the interval at 5.5, it's open. So that remains unshaded. And you connect those two parts. And everything inside here will represent those values. All right, moving on. All right, so we're gonna look at what we call a relation. Let me just erase everything here. All right, so a relation is a set of ordered pairs that obey a particular rule. All right, so you're not going to understand this definition until I work out a question. All right, so let's look at this example here. Now, if x, well, this arrow means that if x is mapped or is related to 3x plus 5. See, we can look at 3x plus 5 as a rule. All right, for the domain. Now, do you remember what domain means? Yes, it's a set of x values. And this here is an interval starting at -2 and ending at +2. Now we're asked to draw its graph. So what we do, we set up a table of x values, starting at this -2 here and ending at +2. And we have all these integers between those two numbers. And then what we're going to do, we're going to use this rule to find the corresponding y values. So for example, when x is equal to -2, this -2 here, we want to know what that y value is. And to know what that y value is, we're going to use this rule. So how do we do that? We just replace x with -2 in the rule. So we have y equal 3x. Now 3x means 3 times x. So it's 3 times -2 plus 5. And that's -6 plus 5. And that turns out to be -1. And you can work out the rest. So this one here is going to be let me see. 3 times -1. That's -3. -3 plus 5 is +2. The other x value is when x is 0. So 3 times 0 is 0. 0 plus 5 is 5. The other x value is 1. So when x equal to 1, we'll have 3 multiplied by 1, which is 3. 3 plus 5 is 8. And the last value, when x is equal to 2, we're going to replace x with 2. So 3, 2, 6. 6 plus 5 is 11. Those are your values. All right, moving on to the next slide. All right, so we can represent a relation on a mapping diagram. Hold on here, guys. Let me go back to the previous slide. Forgot to mention something. When you get these values, right, you notice we get a set of numbers or a set of coordinates. So the first coordinate will be -2, -1, and the other set of numbers will be -1. This -1 here, and what corresponds with -1 will be 2. And then we have 0, 5, etc., etc. Now we get a set of ordered pairs. Can you imagine a small child looking at this handwriting here? All right. So let's go back to the definition of what a relation is. A relation is a set of what? Ordered pairs. So here is our ordered pair. So a relation is a set of ordered pairs that obeys a particular rule. And this is our rule. All right. And the rule changes. All right. So let's move on. All right. So let me just erase. All right. So I'm going to need these values here. All right. So this subtopic says we can represent a relation on a mapping diagram. Now, what's a mapping diagram? So I'm just going to construct a mapping diagram over here. So what you notice, these are the x values from the previous question. All right, so these are the x values. And what I'm going to do is I'm going to draw another rectangular thing over here with the corresponding y values. So this is 8. And 11. So what do we have these arrows here. All right, so this is our mapping diagram. And we call this a one-to-one mapping diagram. Why is it called a one-to-one mapping diagram? Well, for obvious reason. Each element on the domain maps to one and only one element in the range. Right? We have different types of mapping diagram also. We have one-to-many, many-to-one, many-to-many. Later on, we're going to look at what we call functions. Right? Now, we can represent a relation on a mapping diagram. And we can also represent a relation on a graph. All right. So using the same question, we can actually draw up a grid. All right. So we're going to look at that quickly. Oops. All right. So that was -2. x plus 5. So it would have been 3, negative 3 plus 5. So that would have been positive 2, sorry. All right, so to draw this graph, you see, we'll have to set up a grid. Just bear with me with my drawing. All right, so I'm using the same question. So it says we can represent a relation on a graph. All right, so our first set of order pair is negative 2, negative 1. So this is negative 2, negative 1 is there. Then we have negative 1 and positive 2, which is right there. We have 0 and 5, 0, 1, 2, 3, 4, 5. We have 1 and 8, so 1 on x. I must tell you because I'm sketching, this might not look so accurate, but I'm just giving you a little picture of what's going on. And we have 2 and 11. So these are our points. All right, and when we draw them, we're supposed to get a straight line. So watch carefully. Oops. So I missed out that one. Sorry about that. So what you notice, we get a straight line when we represent this relation on a graph. And we get a one-to-one mapping when we represent it as a mapping diagram. All right, let's move on to our next slide. So let me just erase. Yeah, that's better. All right, let's look at this question. It says, if a relation from x to y is defined by x maps to x squared minus 2x, that should be plus 1. Copy and complete the relation diagram below. All right, so basically, this is our relation. X squared minus 2x plus 1. So this is like our rule. Remember I told that the rules can change? And, you know, so this is our new rule. So they give us the x value, which, so these are the domain. And when they give us the y values, they give us the answer. What they're saying that if I put x equal to 0 in this rule, particular rule, you're supposed to get 1. So let's give it a try. So when x is 0, I'm going to have 0 squared subtract 2 times 0 plus 1. Now 0 squared is 0. 2 times 0 is 0. And 0 from 0 is 0. 0 plus 1 is actually 1. So this is actually correct. So we're asked to copy and complete the diagram. So what we're going to do now, we're going to look at when x equal to 1. When x equal to 1 is going to be 1 squared minus 2 times 1 plus 1. So 1 squared is 1, 2 ones is 2. Plus 1. Alright? So according to Badmas, we have to add first. So let us add the two positive numbers. 1 plus 1. 1 plus 1 is 2. 2 from 2. So when x is 1, y is 0. So it's up like that. And then we continue. Alright, let me do the last one too. So, and you can do the rest. So when x is equal to 5, we have 5 squared minus 2 times 5 plus 1. Now 5 squared is 25. 2 5 is 10. We're at the 1. According to Badmas, let us add first. So let's add the two positive numbers. So that's going to be 26. Subtract 10. That turns out to be 1. So when x is 5, y is 6, and just draw a diagram like that. Alright, so work out 2, 3, 4, and 5. Alright, let's move on to our next slide.
That's good.
So this is another example we're going to look at. Alright, determine the range. So range means y values for the relation x maps to x to the 2 to the x for the given domain. So 0 should be there. Alright, so basically they give us the x values and they want us to find the y value. So we're going to use, this is our rule now. You notice this rule change, right? It's a different rule. This is 2 to the power of x. So let's work it now. So when x is negative 2, alright, y is 2 to the power of negative 2. Alright? Now, there's a law of indices that says that a to the negative 1 is 1 over a. For example, if I have 2 to the negative, say, 6, it's going to be 1 over 2 to the positive 6. Alright? So, you know, this example is not really a a great example, because guess what? You might think that this one, and this one are the same thing. And that's all. Alright? Because look at this. You might say, why, sir, where one come from? Well, actually, there's a one beneath it. It's a 2 to the minus 6. Alright, there's a 1 there. What happens? You flip this thing up that side and down that side. When you flip it, the 1 goes on top and the 6 goes at the bottom, but the negative 6 becomes a positive 6. Alright? So we can work this out further by saying 1 over, using the law of indices there, 2 to the positive 2. Alright? 2 to the positive 2 is actually 4. So when x equals negative 2, y is equal to a quarter. Alright, let's look at the other one. When x equals negative 1, y is going to equal to 2 to the negative 1. And that's going to be 1 over 2 to the positive 1. And 2 to the 1 is just 2. Alright, so remember this one numerator came from down here, so let's do the other one. X equal to 0. So we have y equal 2 to the 0. Alright, so 2 to the 0 is 1. There's another law of indices that anything to the 0th power, a to the 0, is 1. Alright, so 0.0065 to the 0 power is what? 1. Anything to the 0 power is 1. So that's our next value. Alright, so we have x equal 1 now. So we have y equal 2 to the 1. And 2 to the 1 is just 2. Alright, and our last number, x is equal to 2. So we have y equal 2 to the 2, which is just 4. Alright, so let me see if I can squeeze in the answer. I think I'm going to erase on one side here. Alright. Okay, so determine the range. So I'm going to write out like this. So y. So these are the range. We'll have a quarter, which is this one. Then we have a half. Then we have 1. This one here. Then we have 2. Alright. So that's the answer. Alright guys, so these are the basic concepts of what a relation is. In our next video, we're going to look at what we call function. Alright, so thank you for watching, and I'll see you in the next video.